Hi everyone, welcome back. Today we're doing counting items matching a row. We're given array items where every single item is an array of size 3 containing 3 strings. The first position contains the type, so type as in phone, computer, and so on and so forth. It seems to represent an item. And the second position contains the color of the item. And the final column, the final index, contains the name of the item. So in this case, Pixel, Lenovo, and so on and so forth. And in this case, we're also given a row representing by 2 strings, row key and row value. This row key over here represents the column, I guess the alias for the column that you want to filter the item by. So if you get a row key equals to type, then in this case, we are referring to the first column over here. And if the row key is color, the second column. And if the row key is name, then that is the third column. And the row value in this case would correspond to a value that is inside each of these columns. The idea is we'll be filtering the list of items based on the row key and check whether if the row key for every item is equal to the row value. So for example, in this first test case, items has 3 rows over here, or 3 items, and the row key that we want to filter by is the color, and the row value is silver. So what this means is we are filtering all items by color, matching for items that has the silver color. So in this case, the answer is 1, because there's only one item matching the given row, which is computer, silver, Lenovo. So for the second example over here, we have a row key equals to type. So type is the first column, so phone, computer, phone, and we're matching for rows that have row value equals to phone. So in this case, we have 2 items. The first one, phone blue pixel, and phone gold iPhone. So the answer is 2. So we are given items, which is a list of 1 to 10 to the power 4 items. And the type, length, color length, name length, row value length is consisting of characters from 1 to 10, and row key is equal to either type, color, or name. So thank goodness, it's easier for us to convert that row name to a certain column that we can look out for. So to solve this question, it's pretty much 2 steps. The first step is to convert the row key into an index. So we'll be using this index to check every item at this index. In other words, pretty much the column that we're looking for. And we're checking in this column for every single item if it matches this row value over here. So with that, let's get started. First, let's try creating a function that converts that row key into an index. So let's do private. We're making it private because this function is only going to be used in this class. You can use any public accessor methods, doesn't really matter, but in this case I'll just stick to using private. This function will return an integer, and let's call this getColumn. And in this case we will take in a string row key, and let's define this function. So if the row key is equals to type, in this case, what this means is we will return 0. Else, if row key is equals, let's say, color, then in this case we will return 1. And else, by default, is going to be 2. So that's pretty much it. And because I come from the land of snakes, let me correct that with by adding the missing semicolons again. And looks like this is great. So let's move on. So in this case, let's first get the column. So let's get column index. This will be equals to solution dot get column. And there's one mistake which I made, which is we want this function to be easily accessible without having to create an object of type solution. So to do that, let's make this function static. This way we can call this function without having to create a solution object. So now that we have the column index, all we have to do is iterate through every single item of type list. So list of string item in items. So for each of these items, let's get so if let's define a count that represents the number of items that matches this row key and row value. Set this to 0, and if this item get column index, in other words, the column at this index for this current row is equals to this column index, pretty much the row key is equals to row value, then what this means is that we have found, it means that this current item matches the row that we set. So we increment count by 1. And once we're done, we return the count like this. And let me fix this with a semicolon, and it looks great. So let's try tracing this out with a simple test case. So let's do the same old routine of tracing this out. Okay, we have items, which is a list of 3 lists, like this, and that's pretty much it. And the row key that we're filtering for is type, and the row value is phone. So let's get started. So the first thing is to get the column index. So because the logic of getColumn is pretty simple, I'll be skipping some steps. Oh, thank goodness, because we traced it out, we noticed that I made the mistake of not passing in the row key, so I'm passing in right now. So let's say the row key is equals to type. In this case, we're just going to return 0. So column index is equals to 0. And the count, let's initialize this to 0. Okay, let's move this in so that we have more space to trace. And now, this item is going to be referring to the first item, phone, blue, and pixel. So let's assign this to this. And the item get column index is going to be phone. So phone equals row value. In this case, row value is phone. So thank goodness we match the first one. So in this case, we increment the count by 1. So count by 1. Let's move on to the second item, computer, silver phone. In this case, we know because this is computer, so we will skip this. Let's move on to the final item, which is phone, gold, iPhone. So because the item in this case is phone and it matches our row value, we will increment the count by 1 again, and we get a count of 2. And we return answer equals to 2. So looks like this approach works. Let's trace it again to be sure that we didn't make any mistake over here. Looks great. Let's run the code. And this passes the test case, thank goodness. So let's submit this to be sure that it passes all test cases. And there we go. So if we specify n to be the number of items, then the time complexity in this case would be O(n), because we are going to, this for iteration will scale linearly with the size of items. getColumn in this case is linear. We are given a row key and it's going to take a constant number of comparisons. We can just assume that it's pretty much constant because it's going to range from 1 to 3 operations here, so it's fine. So yeah, getting a column value at a given index is O1, and checking whether if it's equal to another string is O1 as well. So everything inside this for loop here is O1. In summary, the time complexity is On. For the space complexity, in this case, we use constant space here, and we reuse this constant space variable item. And yeah, looks like the space complexity is O1 in this case. We do not have any variable that is scaling linearly with memory over here. And that's pretty much it for this question. I hope this was useful. And if you like this, please give us a like and subscribe. And we'll see you in the next video.